guess I'm leading today. Okay. Good morning, everybody. Thanks for joining the weekly Core Protocol Sync. It's a light meeting today. We got a couple of people out. Um, I guess Nizar, if you want to go first and give your update.
It was still showing like recording spinning for like
Oh,
15 more seconds.
my bad. I thought you were just waiting on me to start.
That's fine. I don't think I have a lot to share. I just upgraded Substrate to a new monthly snapshot. I was hoping to actually have switch to the latest nightly. Apparently, it's not going to happen yet. There are some interesting problems related to that that appear to be related to nightly itself. Basically, starting the January 20th, the nightly build basically fails with some weird errors related to WASM target. Doesn't make a lot of sense to me, but there was another person that faced the same issue on Substrate. So basically bisected like which nightly is the first that is affected. I left it at that. It just updated to the 19th of January for now. Other than that, I was mostly doing reviews and reading. I don't really have any significant changes to share yet. On Lucheng side, there was this pull request, but it's still kind of in progress. So I think once it's done, we'll go through it.
And what about with the network design?
With network, I went through it yesterday. I spent quite a bit of time on Substrate upgrade. And after that, I just rebased it and updated the dependency. I had like some experiments before. I just rebased those experiments against the latest of what we have. Didn't really move much further than that yet.
Okay.
Okay. Yeah, let's probably jump into what Ivan was working on, into the pilot.
Yeah, sure. I mean, should I give a like some overview about the Uniswap and XYK?
Sure.
Okay. Okay, yeah. Give me a sec. Yeah. Um, Basically, I have two pictures here. Basically, Uniswap is an automated market maker. What does it actually mean? It means that in order to like trade assets, you don't have to like as you do it in the order books. Basically, you do an order. You basically post an asset on some predefined price on which you want to like buy this kind of asset. So, but in the automated market makers, basically the market maker itself, like Uniswap, it actually like gives back you price using some predefined function like XYK, which is for the Uniswap v2. So yeah, but what does like XYK actually mean? The X itself is the amount of like some of the asset, like let's name it asset A, and Y is the amount of the asset B. So and K here is some constant if we are like not printing or giving like new liquidity to this to this asset pair. So yeah, this actually means that like in order to like trade assets, like we actually move on this hyperbolic curve. So basically, yeah. For example, we were here. Basically, some asset was almost had almost the same price as like token A has almost the same price as token B. So and we wanted to like trade token A to token B. So we increased the quantity of token A, and we went to from this point here to this point here. So this is how it actually works. So yeah, let me switch to an editor. Give me a sec. Yeah, here it is. So basically, it works like this. Yeah, let me find the config. So yeah, at first, you always need to like specify an asset ID, like in order to identify which kind, in order to give like some identifiers to the assets. So actually, in my design, the decentralized exchange also has the address. So it's actually a technical account. So it is specified in the compile time. So and there's some MISC LP minimum balance. So this may actually is an option in order to give away some dust for LP tokens. So not to give away, but to discard some of the accounts info if their balance is too low. And also we have the asset ID hash. This is actually used in order to like get deterministically LP token ID from the from a token pair. So yeah, as for the storage, it is pretty simple. We have here the storage map, which is actually we map the asset ID, which is actually LP token ID. So we map it into the token pair, basically. Token pair here is just two assets, X and Y, with their ID and their balance in the DEX. So yeah, the API of the palette looks like this. So yeah, of course we can do swap from asset from here to asset two. So of course we can also create liquidity pool. So we give away some token X with its balance and token Y with some amount. So apart from that, we can also update the liquidity we just created by the lock and unlock functions, extrinsics. So yeah, but we don't specify here the like amount of the second asset. But that's because like I don't implemented like slippage or anything. So yeah, this I just didn't focus on that as it wasn't like my priority in order to like get acquainted with the substrate itself. So yeah, here basically we have some wrapper sound functions which basically check the signature and like deposit all of the events into a WebSocket. So so let's start, I guess, with the create liquidity pool, as it's pretty simple. So basically, it works like this. At first, it derives the LP token ID from the IDs of the X and Y. So it works very simple. Like at first, we just check which of these which of those IDs is greater, and we like sort them. And after that, we just hash them and just decode it into the asset ID itself. So after that, we just check whether like this liquidity exists or not. If it exists, we just exit with an error. So after that, we transfer the token amount from the user, from the caller. So and after that, we just create a liquidity token. So and we after that we issue it to an user and also fill the storage with the all necessary info. So after that, we can go into swap, which is actually a bit harder, as it actually requires to work with that kind of curve, which I showed before. So yeah, we also derive here the LP token ID. So and after that, we ask the user to give us the this token amount which he asked us to sell. So, and after that we do some calculations basically based on the formula of the XYK. So knowing but this k should be always constant. We can derive new x and new y here. So basically new x is an old x plus some new delta which user gave us. So a new y is basically a k divided by new x. So sk should stay the same. From this new y, we just derive delta y, which we should give back to a user. So yeah, and we just transfer it back. Apart from swapping, we can also mutate liquidity in two different manners. We can lock some new liquidity there, and we can unlock it there. So it's actually also pretty simple. We derive the same idea of LP token. So after that, we again do the same kind of calculations. So as we know that the ratio between delta y and y here is the same as the ratio between delta x and x. So we can derive the amount y, which we should subtract from the user balance. After that, we also derive how much liquidity pool tokens we should give away to a user. And we just transfer x and y and mint new LPT liquidity tokens to a user. As for the unlocking liquidity, user can just give away how much liquidity pool token he wants to give away, and its ID. So after that, we just do the same kind of calculation, but like in reverse. We basically calculating the ratio of ratio between the tokens which were given by the user and the total supply of the liquidity, and we just multiply it by x and total x and total y. And after that, we just burn the liquidity tokens from the user and transfer back him his assets. That's how it works in general. I can show some of the simple tests which are passing.
Can you show the mint LP function?
Sure, yeah. Yeah, here it is. It's basically a wrapper around the pilot assets.
Okay. But this is non-fungible token that you are getting, right?
It's actually fungible.
Okay, interesting. Because I
yeah.
believe in Uniswap v3, you are getting non-fungible token that represents like your liquidity in the pool. But I guess it works differently than v2.
Yeah, right.
Yeah.
I mean, the architecture of v3 is actually way different. As for v3, there is a range. As I remember, like you're having the range in which you like give away liquidity.
Yeah.
So this is not the case for v2.
Okay, makes sense.
So yeah. Basically, here's some simple runtime, which specifies all this kind of stuff in the config. As for the DEX address, it can be just random, but we need to make sure that this account actually exists. So there are some assets on this account, at least in this kind of setup. This is
What do you mean by account exists?
I basically mean that for the palette balances, you would have some actual balance there. This is a weird issue. This is how I fixed that kind of issue, which I talked about yesterday.
Okay. What issue was that? Because I know when you do transfers, there are actually two functions. There is just transfer and there is transfer creating or something like that. That will create an account if it doesn't exist yet. Maybe that's what you wanted.
I actually discovered that. I mean, as I remember, like palette essence doesn't have that. So
Okay, so it's just balances.
yeah. So basically, for the transfer, it just goes here. The call stack is that. Yeah. The transfer. Yeah. Let me find it. Yeah, but the issue is that it basically uses the function from the frame support or frame system, something like that, in order to get whether like there are providers for this account or for these assets. I don't remember actually. So I guess I can send you the lines where it actually goes. So yeah, here's prep debit and prep credit. So as I remember, yeah, at first it checks whether it can decrease on the caller side, and after that it checks whether it can increase on the other side balance of this asset. So and it basically goes into this path. So so yeah,
Is
and
this your code, Ivan, or is this
no
this is
no, it's
assets that we're
This is
looking at?
Substrate. Yeah.
this is not my
Okay.
code. No, yeah.
All right.
So basically, you need some kind of existential balance on that account so it doesn't disappear.
Yeah, right.
Is it account? Is it balance in like native token or in this asset specifically?
No, native token actually.
Okay, that makes sense to me, at least. Okay.
So yeah, this was the issue. Yeah, and that's why here for the test purposes, I have like two accounts. One of which is obligatory, like the DEX address. So yeah, I just
Okay, is this like a recommended way to do it? Did you ask someone, or this is just like a way to you
no,
found?
I didn't know.
Okay.
I just found it. Yeah.
Okay, maybe it makes sense to ask folks if this is like a canonical way to do it in Substrate, because often there are several ways to do it, but yeah, it's kind of interesting. So basically
Sure.
generate like a random address that no one can use and just pour some existential tokens there.
Yeah, I mean, that was for design, which came to my mind. Of course, there is a possibility, like to burn like tokens, if the user wants to create some liquidity and just mint them, like yeah, to like swap between those. So it's also possible, but yeah.
Yeah, but then you
decided
cannot necessarily like trace it. It just
right,
disappears and appears out of nowhere.
right,
Okay.
right. Yeah. And there are no like privileged functions in the palette assets in order to like burn using some origin root, for example, or something like that.
Okay.
So yeah, for this kind of asset ID hash, yeah, it needs to be like Blake 2 for the actually yeah, the hash function needs to be Blake 2 because of the because users can mint like any random asset with any random asset ID. So that's why we want to like prevent some of the collisions. Yeah. Also here, like I just mint some token X and some token Y. Yeah. Yeah, there are a bunch of tests which are yeah checking the right behavior for these kind of things. So yeah, for example, for example, swapping between both. So at first we just create some liquidity with token X with 100 tokens of those and 1 billion tokens for Y. And after that, we just check whether we have the same kind of balances between these two executions. In these two executions, we just run in a for loop for 10 times and swap the token X for 1,000. And in another one, we just simply do one swap for the same amount. So, and the assets are actually the same.
Okay.
I guess that's all from my side here.
Okay, thanks, Ivan. I have a bunch of questions.
Mhm.
So first off, did you like read the Uniswap docs and write all this like just from trying to understand V2, or did you look at some example palette in Substrate to write this?
I guess both. I went through a source code of the Uniswap V2, and also I looked at the some of the palettes in the Substrate.
So you looked at the Solidity source code for Uniswap V2.
Yeah.
Okay, and then what palettes did you look at in Substrate for examples?
You mean exactly for the exactly for this kind of DEX, or just in general?
Any palettes that you used just as a, like when you were doing your research on this, like what example code were you looking at, or what example palettes in Substrate were you looking at? It could have been just generic palette to understand how Substrate works, or if there was, I mean, I know Uniswap V2 has been implemented in Substrate before. So I'm just asking if you looked at that code and like to get an idea, or if you just kind of wrote this like from first principles, like trying to understand the actual protocol.
Yeah, actually, I've searched for the for a palette in order to get an idea for the architecture itself, how we build it. But I didn't find like a decent one. So yeah, it's for like general examples. I went through like some of the tutorials. Actually looked at the source code of palette assets itself. Yeah.
So you didn't look at like Akala or
Mm-mm.
Centrifuge or any other chains, how they're doing it?
No, unfortunately.
Okay, that's fine. No, that's great. I'm just trying to understand if this was like on your own or if you were like using an example, but it sounds like it was mainly on your own. Okay. Yeah, so DEXs have been implemented quite a few times in Substrate. So PolkaSwap is a good one. Akala has a native DEX. Seems like everybody's got a DEX. It's like a common use case. I'm pretty sure Centrifuge has one. You might just want to look at some of those to see, you know, like Nazar was asking or saying about what's the canonical way to do some of these things. You might just want to look at those and see as well. Okay. So you're sharing from your IDE. That's fine for the first time. We typically don't do that when we present. We typically present from GitHub, from the web UI. Have you committed all of this code to GitHub?
Yeah. I've committed. Yeah, actually, there is a pull request. Yeah, I will send it to the chat afterwards.
Okay. Could you pull that up really quick just so we can see the commit log?
Yeah, sure. Give me a sec.
Well, if you create a pull request, you probably want to assign someone to review it. Like otherwise, no one knows it exists.
Yeah, right.
Did you not assign anybody as a reviewer?
I think it was in his private repository, so like I wasn't aware.
Yeah.
Okay.
So here it is, the commit log.
Okay.
At first, I just created the palette. yeah, with basically were changes in the palette itself. Yeah. After that, I just added some of the tests. Yeah, which I just showed you. And the last one, I just added the template runtime and node for the for this palette setup. So yeah.
Okay. Any feedback on that, Nazar?
Makes sense to me. I would comment a bunch on like the naming conventions and stuff in the code, but that's like doesn't affect the logic. I'll probably just comment separately. I don't think it's worth time spending on the call.
Yeah, sure.
Okay.
You can comment on that here.
Can you
Okay.
just assign me as a reviewer here?
Yeah, sure. Yeah. Just do it in another browser.
Okay. What are the next steps, Ivan, for this project?
Guess I will ask I guess I will look at the some of the DEXs which are already implemented in the substrate in order to get the idea of how it's actually done. Yeah. If that didn't succeed, I guess I'll go to the substrate builders chat and ask there some help. Yeah. Also, I would wait for a review in order to get some of the comments on that. And I guess that's all on it.
Yeah, I think it's a good approach to just try to tackle it yourself. So you like discover things and then see how other people do it, like whether it was right or wrong, or what can be improved or what can be changed. Other than like looking at others and just replicating it, there's a little bit more creativity when you're trying to figure it out yourself.
Yeah, I also don't think that I would have discovered like the same kind of internals if I would just go into the architecture.
Yeah, I think you did it the right way. That I was just trying to understand if that's actually what you did or not. But now that you've done it, I think it's good to go see what the canonical implementation is. I would assume they're all probably pretty similar. Okay. The other comment I have is a lot of your code was not commented. A lot of your functions were not commented. And so you kind of had to read the code or understand how Uniswap works to know what like lock, unlock, transfer, swap, create LP, all that stuff actually means. And so this is one of those things where it's great to have code that runs, that works, but it really has, you have to go the extra step. There's a lot of things that you have to do that are more than just writing the code, like like using GitHub correctly for like your commits, like using like well-documented pull requests, like documenting all the function signatures. There's the test. You did do tests, so that was great. So I was happy to see that. But there's like a whole bunch of stuff beyond just writing the code that you have to do to get it right to really work well within a team in a large project for like traceability and so that everybody can kind of understand what's going on. And so that would be that, and I know you're not doing this as part of the large Subspace project, but you just have to get in the habit of doing this all the time. That's the way you should just write your code, regardless of whether you're writing it for yourself, for a side project, for a large project, for whatever. It's just a best practice to do. It's one of these things, in the military, when I was in the army, there's special forces, or I guess you call it Spetsnaz in Russia. In special forces, it's not about, being able to do really, really fancy things like, jumping out of airplanes and scuba diving and stuff like that. It's actually just being really, really good at very basic things like shooting a rifle or like how to navigate in the forest or something like that. And it's the same if you want to go from like, an average developer to like a master developer. It's just about being really good at sort of some of these basic skills, which sometimes often get overlooked. So I'll get off my soapbox. Okay, but otherwise it looks great. I'm looks like you understand it and you got a good mastery of Substrate already. So this is great. You understand the runtime, which is just business logic really. So now we'll start stepping out of the runtime and into the complex monstrosity of the Substrate client and altering consensus and peer-to-peer networking in the database and all that fun stuff.
Can't wait till that.
Okay, great. That's all the comments I have.
Thanks.
I'm not really sure if you have anything else meaningful to discuss today. We'll probably have to wait till next week.
Yeah, we don't have anything from Oskin, or he's not here. And the other thing is just to talk about the protocol R&D presentation on Friday. So I'm going to be putting the slides together for that today, and then I'm going to be sharing the deck with you, Nazar, with Lu Chang, and with Oskin. It's going to be about 10 slides, and it's going to be about two slides. I think I've got like 3. Lu Chang's got 1. Oskin's got 1. You've got 3, something like that. So we can sync up on that one-on-one as well as we need to throughout the week to prep.
Okay.
You don't have anything to do on that, Yvonne. Just kind of pay attention.
Okay, I think this is all for recording today. Thank you guys for watching. We'll see you next week.